Hello, Math 151. The function f of x equals 48x all over 11 plus 4x squared has one absolute minimum. Using calculus, find where the absolute minimum value occurs. So we are going to have to take the derivative and set it equal to 0 and find the critical points and test numbers, finding out where does the minimum occurs. All right, so let me go ahead and go to the next page. So using quotient rule, I'm going to have f prime of x equals 48, the top. The root of 48x is 48 times the denominator untouched, 11 plus 4x squared minus top untouched 48x times the derivative of the denominator, which is 2 times 4 is 8, so 8x all over 11 plus 4x squared, all that to the second power. Next step, f prime of x equals 48 times 11 gives you 528 plus 4 times 48 is 192 x squared minus 384 x to the second power all over 11 plus 4x squared. And since I'm going to set this equal to 0, I really don't have to keep writing the denominator. I don't think anything's going to cancel out. So let's do one baby step and claim that f prime of x equals 528 minus 192 x squared all over the 11 plus 4x squared. Okay, so now I'm going to set this equal to 0 and set equal to 0. What I had on the top was it is enough for the numerator to be 0. So 528 minus 192 x squared equals 0. This means 528 equals 192 x squared. This means x squared equals 528 over 192. And that simplifies to, let me just double check my work very quickly. Yeah, it simplifies to 11 over 4. So if x squared equals 11 over 4, then I can claim that x equals plus and minus square root of 11 over 4, which is the same as saying plus and minus root 11 over root 4, which is plus and minus root 11 over 2. Root 11 over 2. So now let me go ahead and go to the next page. Here's so the two critical points that I have is at negative root 11 over 2 and positive root 11 over 2. And remember that our derivative from previous page was, we had it as f prime of x equals 528 minus 192 x squared all over 11 plus 4x squared to the second power. So notice that in this case, the denominator will never be 0. So the denominator, this right here will always be positive. So always positive. So let's pick a number, a big number, let's say a number that we are sure that is to the left of negative root 11 over 2. Let's say negative 10. Negative 10 squared is 100. Okay, and multiply that by 192, of course, is 19,200, and that's negative. So 528 minus 19,200 will give me a negative value. So I have negative values to the left of negative root 11 over 2. Between negative 11 root 11 over 2 and positive root 11 over 2, a natural number to choose is 0. If I plug in 0, I will get just a positive 528 divided by another positive number. It's going to give me a positive value. So every value is between these two critical numbers are positive. How about to the right of root 11 over 2? Choosing positive 10 will result in the same sign, negative again. So we have negative, 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 negative here. So notice that the slope of the tangent lines are negative to the left of negative root 11 over 2. And then become 0, and then they turn around that they become positive. Okay. And in here, they are positive, you know, they turn around, and then they will be negative in here. So notice that, let me just get rid of this error right here, that notice that in here, I do have a minimum, and here I have a local max. So my absolute minimum occurs at negative root 11 over 2. Okay, so and the question was asking precisely the absolute minimum at, so absolute min at x equals negative square root of 11 over 2. So notice that this question was not asking what is, what's the value of the function at that point. In the beginning, it simply asked that where does that happen? Okay, I hope you find this somewhat helpful at least.